production possibility frontier or production possibility curve again. So this is a little advanced, study of production possibility frontier, where I'll be doing it with two goods and with two resources. All right, so let's say you have two goods in question. Until now we were doing, or the previous two videos of mine were on production possibility frontier or curve on with a single resource. Right, so we have just one resource, and technology was limited to that resource, and then how we would plan what to produce and how much to produce, correct? So let's say, but in reality we do have many goods for that matter, but since it's a X and Y axis, so yes, the assumption that we are taking is that in an economy we have just two goods. So with two goods, but yes, let's say we have now two resources, all right? So I have this matrix with me where I have two goods as wheat and corn, okay, and I have two resources. One is the green field and the other is the red field. Now the red field, green field, both are 100 acres, all right, that's what I have. And then I have this, that on the green field, 1 acre can produce 40 units of wheat. So I can say that that's the technology, right? That's the technology that's there. And on the same field, 1 acre can produce 200 units of corn, correct? Okay, so that's the technology given for green field with the resource of 100 acres. So that's the one resource, first resource that I have for wheat and corn. But I have a second resource also, which is a red field. Again, it is 100 acres. And I have the technology out there is that 1 acre can produce 20 units of wheat, and 1 acre can produce 120 units of corn. All right. Okay, so by looking at it, you would, simply we can simply jump to the conclusion that no. So okay, let me go about it. Let me explain. All right. So 100 acres is like, okay. So 1 acre again. So coming back to it, okay. Greenfield has this much technology, this technology, and Redfield has this technology, all right? Okay, now it's like, let's go and do this with 100 acres. So 1 acre can produce 40 units of wheat. What about 100 acres? 100 acres of greenfield can produce 40 into 100, so that gives me 4,000 units of wheat, okay? Similarly for corn, 100 acres can give me 20,000 units of corn for the green field. That's what I've written. On the red field, however, it is that 100 acres can give me 2,000 units, and 100 acres here in green field for corn can give me 12,000 units. Okay. All right. So if I just look at these numbers, 4,000, 20,000, 2,000 and 12,000, and compare it vertically. So green field 100 acres gives me 4,000, and red field 100 acres gives me 2,000. So I can simply say, just if I look at the numbers, okay, so then wheat should be produced at the green field, right? Similarly for corn also I can say that, green field is fetching me 20,000 units of corn and red field is fetching me only 12,000 units of corn. So I believe we should also just plant corn in the green field. Right. So just by looking at these total sum numbers, I can say that, okay, green field is the winner, right? So wheat and corn both should be produced at green field, all right? But that's not the way we look at it. Here comes our opportunity cost. Okay, so for each resource, I calculate my opportunity cost. And if you remember from my previous videos, we calculate opportunity cost for wheat, let's say. So it will be the corn divided by your wheat, right? I have taken wheat on the x-axis and corn on the y-axis. So the opportunity cost for wheat will be that it's basically how many units of corn I have to sacrifice in order to have 1 unit of wheat, right? So that would be my 20,000 divided by my 4,000, that gives me 5. So opportunity cost of wheat in terms of corn would be 5 units. So every time I want a unit of wheat, I have to sacrifice 5 units of corn on the green field. Correct? The opportunity cost for corn would just be the reciprocal, as I explained in my previous videos. So it would be 1 by 5th. So this basically means that for every unit of corn, I have to sacrifice 1/5 unit of wheat. Alright? Okay, so this is just for the green field. This is for the green field I've calculated the opportunity cost for both the goods. Similarly, I calculate the opportunity cost for red field for both the goods. So it would be the same in the same manner, right? So opportunity cost for wheat would be your 12,000 divided by your 2,000, that gives you 6. So every time in the red field I want a unit of wheat, I have to sacrifice 6 units of corn. Okay? And for the opportunity cost of corn, it would just be the reciprocal, which basically means that comes out to be 1/6. That for every unit of corn, if I'm going for every unit of corn, I have to sacrifice 1/6 unit of wheat. Right? Now, in my previous video, I also explained what's productive efficiency, right? So now, we have to actually choose the resource that gives us the most efficient production, correct? And that is linked to the opportunity cost, as I discussed that also in my previous video. Okay, so what we do is basically we compare the opportunity cost for the first good, let's say wheat, in both the resources. Now wherever the opportunity cost will be lower or higher. So wherever the opportunity cost will be lower, we will produce that good with that resource. Okay, so opportunity cost for wheat in the green field is 5. However, opportunity cost for wheat in the red field is 6. Since 5 is less than 6, so that's why we will go for green field for producing your wheat. Right? Because here I have to sacrifice only 5 units of corn in order to produce 1 unit of wheat. In comparison to red field, where I have to sacrifice 6 units of corn in order to produce 1 unit of wheat. Okay, so I'm sacrificing less out here, so that's why I will go with green field for wheat production. Okay, now let's compare for the corn. So corn, this is 1/5 and this is 1/6, right? So mathematically, we all know that 1/6 is less than your 1/5. Okay, so here we have red field as the winner. So for the production of corn, I will actually choose red field. Why? Because the opportunity cost of corn is lower out here. Okay, all right. I have also graphed both of these, resources. So I have taken wheat on the x-axis and my corn on the y-axis, and this was done in my previous video also, that how do I do that. So it's like if you are producing no corn and all the wheat, then you are basically here with 4,000 units, and if you are producing no wheat and all the corns, then you are 20,000. So you get your points, right? And when you join them with the slope, opportunity cost is nothing but your slope of this line, right? So that would be 5. So this should be the slope at the slope of 5. And it's a -1. Why? Because it's a cost involved. You are sacrificing 1 unit in order to get the other unit. Okay. All right. Similarly, this one. So this one is actually for your green field. And this one is actually for your red field. Right. So similarly this, so you get a slope of -6. Okay. All right, now let's go further and just join these graphs and see where is our point of production is. Okay, so from here what we are trying to say is that for the production of wheat I am going for my green field. For the production of corn I am going with my red field. Okay, so basically looking at this matrix, for the production of corn I'm going for my red field. So in my red field I should be producing 12,000 units because that's the technology given. 100 acres can produce 12,000 units only, right? And here in the green field my wheat production would be taking place. So the max that I can produce is 4,000 units. Now let's just combine these two graphs and see where are we. Okay, all right, so the maximum production of corn that can happen is 20,000 plus 12,000, that's 32,000. And the maximum production of wheat that can happen is 4,000 plus 2,000, that's 6,000, right? We need these numbers in order to graph it, right? In order to get the 2 points on the axis. Okay. So now just look very carefully and just try to understand how to graph these 2 points or how to make a joint production possibility curve. Okay, since we have different slopes, I'll be just turning around, back and forth again and again. Okay, so green field has a slope of -5 and then there's this red field with a slope of -6. So obviously since it's downward sloping, so we'll take the flatter one above and the steeper one down, right? Okay, so now we know that this distance, right, in the flatter one, this distance is nothing but 4,000. So the first point that you will draw is basically this 4,000, right? You will take this 4,000 as the point. Okay. All right, this 4,000 as the point. All right, then you know that from this 4,000 and at this 4,000. So if you are at this 4,000, then on the y-axis you are producing this 12,000 units, right? So 20,000 is above 12,000, so you will go from the down. So you will plot this 12,000 out here, right? Okay, and since you are producing wheat, which is 4,000, so that's what you have on the x-axis. Y-axis you are producing corn with red field, and that's 12,000. So that's why you will start with this 12,000. So this 4,000 and 12,000, that's your first point. Correct? Now this 12,000 is the maximum that you can actually produce on red field, the corn, right? On green field, you can actually produce 20,000 corns, right? Just add these two up, 12,000 plus 20,000, that gives you 32,000. So basically on this y-axis, you will come up to this 32,000, and this difference should be your 20,000 of green field, because this is your red field and this is then your green field. You understand me? Right? So this 32,000, the maximum that you can produce, minus the 12,000 that you have marked, the remaining is what your 20,000 is. That represents your green field corn production. And that's where you form this first triangle. So that's one point, the maximum of corn production that can happen, 32,000, right? 4,000 you already marked out here. 12,000 was this point where the green field is producing corn, right? The maximum amount of corn that red field is producing, not green. So that's 12,000. And then the remaining, you will just draw perpendicular out here. This 2,000, from where do we get this 2,000 is basically this one. So the red field, the remaining wheat production that can happen in the red field, right? If I want to join, is this 2,000. So that's how I get 6,000 here. 4,000 plus 2,000, 6,000. So the maximum I can go is up to 6,000. And so this difference is nothing but your 2,000. which is for the red field. So this triangle basically is for your red field, and this triangle is basically for your green field. So this is how you join both of the graphs, and then this is your concave production possibility curve, and it displays your increasing opportunity cost. So your opportunity cost is increasing from 5 to 6 out here. Do you understand this? Okay, so this, all right, this 12,000 and 4,000, and yes, all the points on these, again, production possibility curve are your efficient points, correct? So this 4,000 and 12,000 is a point on this curve, so it's an efficient point. Okay, now let's just see if I go back, and so this 4 and 12 are done. If I go back and see that, what if I had chosen 2,000 is produced by red field and 20,000 of corn is produced by, let's say, your green field. What if that? So if that's 4, let's say that's 3 and that's 2. All right, so let's say that's my 2,000. So let's say that's my 2,000, and then let's say I have 20,000, right? So 2,000 and 20,000, I just draw a point out here. That would be my 2,000 and 20,000, correct? Now this point, let's say if I say this point as T, this point is an inefficient point because it lies under your production possibility curve, right? Inside. So it's in the set. It's not on the line, but it's inside it, right? Inside the triangle. So it's an inefficient point. That is, I can actually increase the production of one without decreasing the production of the other, or I can actually increase the production of the both of the goods, right? So it's an inefficient point out here. So what I'm just trying to say is that all the efficient points on individual graphs are not necessarily efficient points on your joint production possibility curve as well. All right. Now this basically tells us that when we have more than one resource, right, then we use the, use the resources in a way that both of them combined together give us the most efficient outcome. Individually, the outcomes might be different, but when joined together, the outcome should be the most efficient one. And that is actually judged by your opportunity costs for the goods involved, for both the resources. Wherever the opportunity cost is lower, that good is produced with that technology or with that resource. Do you understand? Right? Okay, so that was my lesson on production possibility curve advanced level. I'll be coming up with more videos on various other topics. See you next time. Bye-bye.